everyone! Ako si Abby. I am one of the science communicators at the Mind Museum, and welcome to another installment of Mind at Home. So, dahil gusto natin na mapabagal ang pagkalat ng COVID-19 and to help us to flatten the curve, please stay at home as much as possible. Many of us are still asked to stay at home right now, and this means that we can't go to museums yet, and we can't go back to our own schools yet, or we can't go to visit the school. And even though the stay-at-home orders have relaxed in a lot of areas in the country, it doesn't necessarily mean that the virus is gone. The virus is still there, and there is still a chance that you might get infected. So please limit your going outside unless you really need to go out and it's really necessary. And when you do, please always wear a mask and remember to wash your hands with soap and running water for at least 20 seconds. So now we ask the question, can we still, while staying at home, can we still have fun while learning at the same time? Our answer is yes, because here at the Mind at Home, we have a lot of fun science activities where you can both learn interesting scientific concepts or fun facts while enjoying the activity and learning a lot about it. So now, let's begin. So for today's Mind at Home activity, we will actually be dealing with a topic that I'm sure we've encountered constantly, especially these past few months. And that topic is a virus. So when we talk about viruses, usually a lot of negative ideas or images pop into our head. Kapag virus ang pinapag-usapan natin, malamang naisip natin sakit, we think of disease and we think of the damage that is inflicted upon us or on other organisms. And for most people, it's always scary to think about viruses. Especially now when we see just how much havoc they can wreak on us. And I think it's true that yes, viruses and what they do to us and other organisms can be scary. But I also think that actually understanding how viruses work and how they're designed may actually help us understand and better deal with our situation. So, what are viruses? What are they made of? Ano nga ba ang mga virus? At saan sila gawa? So as you already know, viruses infect other organisms. And according to literature, viruses are these incredibly small particles. Sobrang liit ng virus. And they are made up of 1. A nucleic acid genome. 2. A protein capsid. So a protein capsid is a container or a casing made out of proteins. So, para siyang lalagyan ng ibang gamit ng virus or ibang parte ng virus at gawa siya sa protina. And some viruses actually have other proteins in them and also a structure called an envelope. So, right now, you're probably wondering, what are these structures? So, ano nga ba mga ito? At ano ginagawa nila? So, to know more about them, today, we will actually, for our Mind at Home activity, we will actually be making our very own Viral Capsid Model from materials that we can find at home. So, to make our own Viral Capsid, the things that we will be needing are, so first, we need a template. And for the template, we'll be putting a link down below on where you can get it. And we actually printed the template on a sheet of paper. Hopefully you can find vellum paper, or if not, you can use like regular bond paper or scratch paper, which is more advisable, and then you can just stick it on cardboard paper or cardboard boxes and you can cut it. Just make sure that your paper is stable enough for you to be able to fold it. And aside from the paper and the template, what you'll also be needing are yarn, scissors, tape, a ruler, and cotton balls. Okay, so what we actually did for the template that we got is we drew some more lines. So as you can see, we drew lines in pink, and these will be the flaps for the viral capsid structure that we'll be making. And then, as you can see, I actually marked some of the triangles in blue. Okay? So, those blue ones are the parts that we will be cutting along later on. So, just a quick, I want you to pay attention to the triangles because later on, we'll be talking about them. So, what we did was we actually folded along all the lines using a ruler to make the edges a bit sharper so that it'll be easier to cut and fold them later on. So after cutting, what we will actually have are parts that will look like this. So this is the first one, and this is the second one. Notice how it looks like a crown. So there are 5 triangles here, and here the bottom part also has 5 triangles. Okay? So now, what we're going to do is, we're actually going to tape these. So, you're going to tape them all together. Okay? And they're going to form, so once you put them all together, they're actually gonna form something like this. Okay?
Okay, so once again, here is a close-up version of me taping together the triangles to be able to make the cap part of our viral capsid model. So once you finish taping all of that, you're also going to tape the flap part at the front, and you're also going to tape it at the back to make it more secure. And now, you have your cap.
And we actually cut, so this actually had flaps on it. So you can see here, right? They have flaps. Or there's a long strip here that will act as the flap later on. So we actually cut the flaps. So I don't know if you can see it. So here, we actually cut them so that they will be easier to fit later on in our other structure.
So a close-up of it shows that I snipped some of the parts of the flaps, and I cut these little triangles off of them to make them diagonal so that they can fit inside the cap.
So the same goes for this one. You're going to tape the 5 triangles, and then you're going to form something like this. So it's like a cup, right?
So for the larger cup structure, we're going to do the same thing that we did with the cap. So we're going to tape the 5 triangles together, and later on we're also going to tape the flap at the very last triangle. And we're also going to tape the inside to make it more secure. And there's also, you'll notice is there's also going to be a leftover triangle that we're also going to tape in order to make the final cup.
So once you have these 2 together, so you have here your cup and you have your cap, which will be used as the cover for this, right? So you see that it's already coming together. And later on, we're actually going to put them together, and the challenge for us is we are going to try and to fit our yarn and our cotton balls into that viral capsid that we're making. So it's going to look something like this. And then we're going to put our yarn in, and we're going to put cotton balls. So I have 3 here, and look, I put them inside. And then we're going to close it, and now you have your viral capsid model. So interesting, right? And you can actually make more of these, and you can also challenge yourselves to actually use the triangles that you have to build different designs if you can. Now notice that this viral capsid that we have, I asked you earlier, right, to take note of these triangles. So you see that this whole structure here, this is actually called an icosahedron. So it's actually made of a number of the same triangles. So imagine, they're just like bricks or Lego. So, di ba kapag gumagawa ka nung bata ka, kapag naglalaro ka, meron kang Lego or meron kang mga bloke, di ba pinagsasama-sama mo sila para makabuo ka ng mga tore, para makabuo ka ng bahay. So, viral capsids actually act according to the same principle. Or the same principle could be applied in a simple, when you think about viral capsids. So, you have these smaller pieces, and when they're arranged together, they actually make larger structures, right? So you have these. And these triangles that we have, they actually represent structures called capsomeres. So, viral capsids are actually made of a combination of a few different proteins and like capsomeres, and they form together to form this viral capsid. So, remember when I said that the shape we have, this is called an icosahedron, right? And it has actually 20 triangular faces. So, the icosahedron is just one form of a viral capsid. But viruses and the viral capsids actually come in a lot of different forms, or they have a lot of different designs. And some examples are the bacteriophage, which we have here. So this is the viral capsid, and you can see that it's designed like this, but it has a head like this, but it also has other structures like this tail, right? And one that's actually very common right now, or we've seen it all over, we've seen illustrations, we've seen pictures of it, we've seen it all over the news, and these are coronaviruses. So this is what a coronavirus looks like. So their viral capsids are all made of smaller subunits called capsomeres as well. And these capsids actually act as your container. So as I said earlier, we have here your extra proteins and your nucleic acid genome. So, the nucleic acid and other proteins which are contained here are protected by your viral capsid. So, moving on, I also want you to pay attention to what you put inside. So, what exactly does this yarn represent? So, as I said earlier, this yarn that we have here actually represents your nucleic acid genome. And this nucleic acid genome is actually made of either DNA or RNA. So, a couple of weeks back, actually in another MAH episode, one of my fellow Mind Movers, Mind Mover Mario, actually talked about nucleic acids and mutation. If you want to learn more about that, then I highly suggest that you go ahead and check it out after this video. It's on our My Museum page as well. So, basically, the nucleic acids in viruses work much in the same way as in other organisms. So, these genomes actually have instructions written in the form of a genetic code. So, I actually made a representation. So, the genetic code, so they're a combination of your nucleic acids, and they actually correspond to the direction of the infection of the organism, and a blueprint for building new viruses, and maps of actually how to spread the newly made viruses. So, nakalagay dito sa nucleic acid genome natin, parang instructions kung paano bumuo ng bagong virus. But if you notice, viruses are relatively more simple compared to the other structures that we've encountered, such as cells that we've seen in the past MAH episodes, right? So, viruses actually don't have all the tools and the power to replicate or to make more of themselves, despite having all these instructions. So, we see now that the structure of viruses are less complex, and so they need or they require other things to be able to make more of themselves. And how do they do that? How do they find materials and machinery to be able to reproduce or to replicate? Well, the answer lies in the host. So, to be able to make more of themselves, as I've said, viruses actually enter specific cells of specific organisms. And when they do, a combination of circumstances can actually lead to the viral infection manifesting as disease in the host. So, the design of the virus, as we've seen earlier, they have different designs, they look different. It's actually what determines what kind of organisms and what cells they can actually infect. So, think of it as only having one special key, or maybe some have a specific set of keys that can only unlock a certain lock or certain locks. So, once it has entered the host cell, the viral genome can actually direct the cell to use its own tools and materials to build and assemble more viruses. But if they can't enter the cells, then of course they can proceed, right? So, you have to remember that not all viruses can infect us humans and cause disease. Some can only do so in plants, in bacteria, and even fungi, to name a few. However, we have to know that our human activities have also made us and those around us vulnerable to more viruses. When humans come into contact with other animals that carry viruses that could initially infect us, whether it's through hunting activities or converting wildlife habitats into industrial spaces, it's possible that later on, the virus evolves enough or mutates to gain another key that allows it passage to a new host species. So yes, when you think about it, viruses can be scary, but that doesn't necessarily make them bad or evil. We now see that their infectious activity is brought about by their need to make more of themselves. The pandemic that we're currently facing has shown us how such tiny particles can affect us so dramatically. But we also have to recognize how our actions may have also contributed to our present situation. What will be left for us to do later on is to make more responsible actions and decisions, especially concerning how we treat our environment, today and in the future. So that's it for today's Mind at Home episode. Thank you so much for joining us again today. And if you have any questions related to today's activity about viruses and viral capsids, comment on the video and we'll do our best to answer them. If you enjoyed today's show, please don't hesitate to follow us at the Mind Museum, our Facebook page, at the Mind Museum. And don't forget to like, and I hope that we'll see you again in our next episode. If you do try this viral capsid activity, we would appreciate it if you posted it and tagged us. Again, thank you, and I hope you have a good day. Bye!